Hi, welcome to Intro to SQL. Today we'll be going over the basic commands that you'll use in SQL in order to run queries that you need to do. We will also show the equivalent of the SQL code in Python for those who are familiar with the language to make the learning process a bit easier. And then at the end we'll show an example of a more complex query and we'll go through step by step what each line is doing, so it won't be as intimidating in the future when you have to write or understand a more complex query. So in order to make the process of understanding SQL a bit easier, we will be showing the equivalent in Python. And in the following slides, you'll see the code label accordingly, whether it's SQL or Python. So these are the 6 basic SQL commands, which you will use pretty much all the time. This is just a brief description, but later on we will go into more detail over each of them and then eventually see them run in a real example with a more complex query. So before we get started, we need a table, and we will be using pandas here to generate a data frame, which would be the equivalent of a table in SQL. And here we just have a basic table with a few people, income and date of birth. But once we have all this information, we can go ahead and start writing queries, and you'll be able to see what those 6 commands actually do. So the first thing we're going to look at is the select statement, which selects data from a database. And in this case, we use an asterisk, which selects all the columns from table A. Generally, it's good practice to only select the columns that you will use, so it runs as fast as possible. So the syntax for the select statement, which you'll see on the next slide, is to have a series of column names, and we separate them by commas. The from statement goes hand in hand with select. So since we use select to specify which columns or which data we want, the from statement will specify which table we're actually going to look at to get that data. So in this case, you can see we've selected every column, which is the same as the asterisk we used before, so our output is the same. So since the naming column A, B, C, and D is quite generic, we would like to add aliases to give them a better description and help us later on when actually writing the queries. So in order to do this, all we have to do is add a space between the column and then the word, which would be our alias name. So the where statement allows us to apply a filter to the data. So in this case here, we are taking column C, which is the date of birth, and we're applying a filter greater than a certain date. So as you can see from the output, we're only getting people born after that date that we specified. So now we're going to create a second table called table B using Python again. And we'll use this to show examples of group by, having, and order by in the following slides. So when we see group by, this signifies that we have an aggregate function in the select clause. And in this case we do, so we need to tell SQL to aggregate the ag function, being sum in our case, by the non-aggregated columns. What this means in our example is that we are summing up the purchase amount for each employee. So as you can see, employee 1 is the only one that has made more than one purchase. So in our output, we see that for that employee, they're getting the sum of all their purchases made. Having is the same as a where clause, but it only applies after the aggregation. So in our case here, it allows us to filter for purchase amounts greater than 14, not for a single purchase, but for the sum of the purchases for each employee. The order by clause allows us to sort the data, and in this case we can do descending, but we can also select ascending, which you'll see in the following slide. So in this case here we are specifying column D, which is the income, and as you can see from the output, it is in fact decreasing or descending. So very similar to the previous slide, we are using order by again, but in this case we are sorting it by ascending values. So as you can see from the output, the income is starting low and increasing. So now that you know the 6 basic commands in SQL, we will also cover a few extra tricks that will allow you to handle more situations. So this is a description of them, but we'll go over them in more detail in the following slides and show you a few examples. A coalesce is a way to handle null values in the table. You can think of it as a nested if statement going through each value until you hit a non-null and then selecting that value. And if the table happens to be only nulls, then a null will be returned. So in our example here, we are doing a coalesce of column A, B, C, and D. And since we have no null values in column A, we are getting column A is being returned each time. So limit is used to simply limit the number of rows we get from a query. And these rows will be returned in a randomized order unless we use an order by statement. The distinct statement is a way to make sure that we don't have any repeats. So when you use it, you will only get unique values in the data. But don't use it too liberally because it does count as an aggregation, so it will slow down your query quite a bit. The count function returns the number of rows returned by a specified query. And in the code below, you can see that this is the equivalent of value counts in Python. And it's just returning the number of unique values. Sum returns the total sum of a numerical column. And in this case, it would be the sum of the purchase amount. But we are also grouping it by employee ID. So each employee will get the sum of their purchases. So now that we've seen examples and lots of basic commands in SQL, we can now look at a more complex query, as you can see in the slide. It might look pretty intimidating, but once we break it down into separate pieces, you'll see that we've learned everything that we need to know in order to understand this query. So the first thing you want to do when looking at a complex query like this is to check the from statement. And in our example here, you can see that only one table is listed. So now we know that every column we select is referencing the same table. Then the second thing you'd want to look at are these select statements. And in our case here, there are multiple columns being selected. So let's go through step by step and look at each column one at a time. So the first column is pretty simple. It's just selecting the whole column with no special attributes being added. And it's just called PC9. So let's skip on to the second one. Our second column is a lot more complicated than the first, as you can see. Not only do we have a coalesce, but within the coalesce, we also have two case statements. And if you remember from before, our coalesce is simply finding the first non-null value. So if you look at the first case statement, if the mark for store key is not an empty value, then we will get a non-null return. And then it won't have to look at the second case statement due to the nature of the coalesce function. And then if the mark for store key is in fact empty, then that will return a null. And then it will go on to the second case statement. Then, as you can see in the second case statement, the ship to customer key, if that is not empty, then it will return a value. So then that will be returned. And if that's also empty, then it will just return a null. So a case statement in SQL is the equivalent to this one-line statement that we've seen in Python before. We are just taking this column and replacing the empty values with a nan value. So now if we take a look at just the Python aspect of this, we also need to incorporate the property of coalesce that removes the null values. So by simply comparing the store key and customer key to see if it's of type string, that will provide the same thing that the coalesce gives with the removal for nulls. So in the third column, we are using the split function to split the product size code by an empty space and then selecting the first element. So you should note that in SQL, the first element is indexed by a 1 rather than a 0, like in Python. So once we have the first element after the split, we are saving it as a size 1. So column 4 is very similar to column 3, but rather than selecting the first element after we do the split, we're going to select the last element. In order to get the number for the last element, we're going to use cardinality. And cardinality simply counts the number of elements in the set. And by taking that number, we essentially get the last element. So we're using that inside these square brackets as opposed to the 1 like we did before. And then once we have that, we will be saving it as size 2. So as we get down to the columns 5 and 6 of our select statement, it gets a bit more simple. So column 5 is simply the timestamp. And then column 6 is the sum of adjusted demand, which is an aggregation. And if you recall from before, this means that we'll have to use a group by at the end of the query. So as we continue on past the select statement, we see a where clause. And in our case here, we are just using it to select data from the year 2017. And finally, we get to the group by statement. And here we are just grouping the adjusted demand over the columns 1 to 5. So there you have it. You've gone through this complex query. So if you remember, just go line by line and start with the from, then go to selects, go to where, and then at the end do the group bys and handle any of the having clauses if there are any afterwards. Because if you remember, the having clauses apply the filters after the group by. So in all the cases we've seen so far, we've only been using a single table. Even with the complex query that we did, it was only looking at one table. But now we're going to start looking at more than one table. So one way to handle these is by using join statements when you're trying to select which parts of the table you want from each table. But the easiest way to understand these is just by looking at the visualization. So if you look at the chart, you can see for the left join, we're taking everything from the left table and then only the overlapping aspect of the right table. And then for the right join, we're taking the right table plus any of the corresponding IDs from the left table that match the right. So there are two other joins you should be aware of: the inner join and the outer join. So for the inner join, it requires that both tables have the ID, otherwise the value isn't kept. And if one of the tables doesn't have the ID, then it doesn't show up in the query result. And the other is the outer join. And so the outer join keeps all the IDs that exist in either table. Even if one of the IDs is missing from the other table, the row is kept and then the values are just filled with nulls. So now we can see an example of the left join using the table A and table B that we created earlier. So in this case, our left table would be table A and our right table would be table B. So we're going to take all the IDs from table A, which is 1, 2, 3, and 4, which is why you do not see the ID of 5 from table B. And so when you join to table B, you'll notice that ID number 3 is missing from table B, which is Scott Gonzalez. And that is why there are NaN values set for the output. So using the same tables for the right join, we can see that we have IDs of 1, 2, 4, and 5. Since ID 3 is only present from table A, it's just not included in this join. And since ID 5 is not included in table A, there's obviously no information. So that's why you get NaNs for columns A, B, C, and D for ID of 5. So on to inner join. And if you remember, inner join is only going to keep the IDs that are common between both table A and table B. And in this case, it would be ID 1, 2, and 4. And since they have common IDs, obviously there are no values that are missing. So hence the table is full and there are no NaNs present. So when we do an outer join on these two tables, we get all the information present in both, since it is keeping the IDs from both tables. It's almost like a combination of the left and right join. So you can see the missing information for ID 3 and then also the missing information for ID 5. So rather than omitting either one, the outer join is keeping all the IDs and just filling in the not a number when there's no corresponding ID from the other table.